Bom dia, pessoal. Bom dia a todos. Sejam muito bem-vindos para mais um webinar aqui da VDI Brasil, hoje em colaboração com o Instituto Qualidade Automotiva, o IQA. Hoje vamos falar na nossa série, né, de webinar sobre Indústria 4.0. Hoje nós temos a oportunidade de juntar Indústria 4.0 com um tema de engenharia mecânica na veia, né, que é a tecnologia de aparafusamento. Ou seja, nós vamos ouvir um pouco o que vai mudar em relação a cálculo de juntas, em relação a tecnologias de medição e a processos e normas de documentação. Então, para isso, nós temos um dos maiores especialistas e um dos líderes dentro da VDI na Alemanha, que lidera esse processo de transformação e de atualização dos principais manuais de boas práticas na área, o Markus Fischer, que vai se juntar a nós em breve e vai apresentar tudo que está acontecendo mundo afora nessa área e vai fazer essa apresentação em inglês. Durante a fala do Markus, fiquem à vontade de utilizar aqui a função Q&A aqui em cima do Zoom e mandem as suas perguntas. Podem mandar tanto em inglês quanto em português, dependendo com o que vocês se sentem mais confortáveis. Rapidamente, eu vou só contextualizar um pouco para quem não conhece a VDI Brasil, né? A VDI é uma das instituições na Alemanha que vem acompanhando esse processo de Indústria 4.0 desde o início, ou seja, no nosso jornal interno da VDI, que vai para 500 mil de engenheiros toda semana, foi o primeiro veículo, na verdade, a publicar o termo de Indústria 4.0 em 2011. Então, desde então, nós estamos acompanhando de perto esse processo e uma das principais funções da VDI na Alemanha é a publicação de diretrizes técnicas ou de manuais de boas práticas em engenharia, com o intuito de transferir conhecimento da academia para o mercado. E nós aqui, como VDI Brasil, o nosso papel é justamente nesse sentido de transferir esse conhecimento documentado e prático que temos na Alemanha para a realidade, para as demandas do Brasil. Então, esse webinar vai muito nesse sentido hoje, né, de termos essa primeira aproximação com as últimas novidades na digitalização da área de aparafusamento. Então, eu espero que seja interessante para todos vocês. Nós vamos fazer, depois da fala do Markus, agora na sequência, nós vamos fazer uma rápida sessão com duas perguntas para conhecermos um pouco mais sobre o interesse de vocês no assunto, né, para detalhar isso um pouco mais e para podermos, no futuro, oferecer cada vez mais serviços detalhados voltados a essa demanda. E já adiantando, né, que nós estamos em preparativos bem avançados junto com o IQA para poder oferecer no Brasil medidas de capacitação voltadas e certificadas com essas novidades que estão surgindo na área de aparafusamento que o Markus vai nos apresentar agora na sequência. So, switching to English, I would like to welcome once more Markus Fischer here with us. Thank you very much, Markus, for taking the time during your home office days to share some of the news with us with what is going on in fastening technology. And without taking any more of your time, the virtual floor is yours. I'm going to pass you on the controls of the screen. And please, thank you very much for joining us today.
Yeah, hello everybody. Thank you very much for having me. Thanks to Mr. Klingberg. I would like to start my little presentation by starting the presentation. Just a sec. By asking you a question, and I would like you to take a few seconds to answer it for yourself. Is the industrial fastening technology ready for Industry 4.0? Because what I learned in the past and today, of course, as well, is that many people have many different views on Industry 4.0 and also on industrial fastening technique and what belongs to that and what's not. And there is also the question of, are the machines ready for the challenge or the opportunities? Are the processes in place? And are the users ready to go along and really leverage the possibilities here? I would like to answer that question and give you my view on that point by using specialty or a specific area of Industry 4.0, the expert systems, and tightening technology, depending on who you ask. There are people who really consider that in tightening technology, the Industry 4.0 is already there. They use words like artificial intelligence. They don't even need expert systems anymore. That comes from calculating joints is no issue at all. Machines can do that. The design is more or less automated, and also process control and so on. That's depending, of course, who wants to sell you which software, I have to say, or on which specific area those people are working. On the other hand, you have a lot of people which have a good gut feeling still, and they see that tightening technology is there for more than 2,000 years. And we did it this way in the last 100 years, and we will do it like that in the next 200 years, and there is no issue. There are challenges as well, and I think there's room for improvement there as well. And I think we are very much in the middle in there. The current status is, depending where you're working and in which company, somewhere in between. And this in between is pretty a big void. It's pretty huge, the area where you can be in there. I would like to give you an overview on the tightening technology by using a graph, which is pretty suitable from my perspective. The graph is a product safety pyramid. It starts from the minimum requirement, the product safety, which is globally and everywhere the same. This is a minimum requirement. And in the end, the green top, the proof, is of course necessary to show off our customers and lawyers and so on that we did everything right. But of course, in the middle, we need to maintain also the costs. We need to make sure that we are still capable to perform in a global market, and we need to make sure that our processes getting streamlined and we are able to join our parts together. So this is where I want to guide you through and show in the things between how it works with the VDI and also how Industry 4.0 is working out there. So as I said, product liability and safety is the basis of everything, no doubt about that. And we need the proof on top of that. And if we think about VDI standards, and that's something I get a lot if I have a webinar lately in Japan or in the United States, everybody is asking me, who cares about VDI in my country? I would say nobody. But I beg to differ and disagree here, because there are several reasons why you should care about the VDI, because it's provenly best practice, especially in respect for fastening technology and the processes around that. And customers, of course, require those and allegiance with the VDI standards. And that's not only true for the OEM sector and the big automotive companies. The reason for that is that they are not that they don't have too much money to spend, or they don't worry, but they know that from a technological point of view and from the economic point of view, the VDI standards are just best practice. Another big point is that the VDI standards, since they are pretty much up to date, and we do a lot of revisions every year on several standards, it's a strong indicator for state of the art and science. And this is with respect to the product liability law, of course, very important. And so if something bad happens and you are in the court of justice, everybody will check on the given standards. And since VDI standards are translated not just only in English, but several standards also are available in Mandarin and several other important languages, everybody can expect that you are up to date with those standards as well. And the last but not least, and this I will show you in the next slides as well, sometimes the VDI is the only source to tackle challenges in your industry with respect to tightening technology. There is nothing else available. And therefore, you sometimes just even have no chance to but cope with what the VDI is giving you. And the good thing about this is that everybody, private person and company, can join the VDI and form the VDI and help to make them better, the standards. So to start with, there is a very well-renowned standard in the world from the VDI. That's the 2230-3 and 2230-1. It's a calculation of joints. It's just one screw you can calculate there. It's a 180 pager. And it's in the market for several centuries right now. And so, before I started to work in that group, they also published a part 2 on the finite element method for joint calculation for multi-bolt joints. And that was also very well received in globally to be used as well. And what we learned in that time is that there is a great gap between the theoretical approach of many designers and bolt designers and engineers on the one hand, which are doing the calculations on how much torque you need to get the specific preload on your joint, and the people who have to do it in real world, in real life, in their assembly line, and the people who are planning those assembly lines. And so we decided to support all of those. And we focus in that standards, which is in the making, how people can validate their calculations by using the tools in the assembly line, and make sure that everything is then really working, and also supporting the engineers to figure out what is the spread of the preload if you use specific tools, and have all those influences in place. So this is on a basis of alpha A, the tool uncertainty factor, and I'm pretty sure that this standard will help a lot the people to understand each other and make a better job. Joint calculation and design is, of course, always combined with the risk analysis. I was pretty happy and stoked to see that AIG and VDA joined for the handbook on FMEA. So we have here standardization on a global basis, which is helping people a lot, and with respect to the proofs, the documentation in the end. So for every product you build, is a coffee machine or a car, you need a risk assessment, and depending on the systems you build in your product, you need to have different risk assessments. So that's the reason why you have also for functional safety and ISO 26262, where you get in the end an automotive safety integrity level, as ASIL level 1 to 4. And many people forget that even with electric systems, like in the case of functional safety, there is a hardware area as well. So the current is just moving, and the data is moving throughout the car if the plugs are in place and the wiring is okay and the joints are there where they have to be. So you need to take care that you manage your risks here, and you prove that you did everything in your powers to ensure safety of your products. And that's something we can see also in quality management. Since 2015, we have the ISO 9001 in the current revision. And there you have that focus of risk awareness and how to tackle risks. So this is, as you can see already, a red line moving upwards, that pyramid. And in addition, 2016, the IATF followed through the 9001. And since I work a lot with companies which are in the phase of qualification for the IATF, I train a lot of those people as well, and also the auditors. And I was, when I got the 2016 version in my hands, I was amazed how much you can transform into tightening technology, and how big the impact was on the tightening technology. And I would like to show you a little example of that. Just some aspects from the IATF. So if you just choose some of the headlines from the IATF, there is almost everywhere a direct link to solve that issue or to tackle the requirements of the IATF with a VDI standard. So sometimes you really must have to work hard to find a solution with respect to fastening tech if you don't know that the VDI already did that for you. And you don't have to invent the wheel new, you just have to follow the stuff from the VDI. I'm saying just, I'm a standards nerd. So I have friends still in the normal world, but I of course like standards. But I can promise you, if you get into those standards and you discuss it with your colleagues or with experts, you learn that there is a lot of to gain if you follow up on them and you interpret it for yourself. I would like to make that point on one specific area, the error proofing. And error proofing on basis of IATF can be done in fastening tech with the VDI VDE 2862-1. And that's guideline is also very well known, because you might have heard, if you work for a German automotive company, for example, that there is a categorization on the joints called A, B, C. A is for safety critical, B is for functional critical, and C is for uncritical joints. And so if you have done your risk analysis on the bottom of the pyramid, then you know where your products and your joints are safety critical. And in order to maintain safety and to ensure on an economic way that you can assemble those and then have also documentation in place, you can use, and you should use, 2862-1, because that standard is also helping you with respect on what are the requirements on the capability of machines the process capability and also the measurement equipment capability. They are pointing to other VDIs, and they just supporting you on if you have a functional critical joint, what your tools have to do and your processes have to look like. And the last point in that line is the capable tool parameterization. And I would like to show you what is meant by that, by the capable parameterization of a fastening tool. You might recognize that from your daily business. If you have a torque angle trace and you want to tighten to a certain torque, then you usually monitor the angle. And that angle should be in a specific window together with a minimum maximum torque. And that's the green box, also called the Niner field. And this is something which is pretty old. It was in the business even before 2012, when the old 2862 highlighted that you need a assembly and a monitoring value. And what was already there with respect to Industry 4.0 is that you can not just say that's an okay or a not okay tightening, but you also can give the assembly line information and the worker information on basis where you stopped. For example, if you would have gone to Windows 7, and it's clearly a not okay because the torque trace would be too steep, then you could figure out why this happened, and then give the worker, for example, the possibility to do rework. You could also automatically give the tool the right parameter set to do the repair work with, and also maybe give the line the information to put out the product in order to have rework. So there was the first small steps were there, but to be honest, nowadays modern tools and systems can do better, very much better. And 2016, when the IATF came out, there was of course a request for more. And just picking out the error proofing aspect of the IATF. If you look at a typical trace of a little bit more sophisticated tightening for self-tapping screw, for example, then you see a torque angle trace like that. And if you see the little green window there, then you see that there is a lot of which is going on just before that. And it would be a pity to lose the information we see beforehand. And to be honest, that green window is just not all of it to ensure the safety of your tightening. Because if you really cut the thread into your material, happens way before that green window, and you need to make sure that you measured what happens there regarding with torque and angle, so you can see that this is okay. So a capable parameterization in the upcoming revision of the standard will mean that you have more monitoring. In an old way, an old-fashioned way, you would put windows there, and of course, the tightening in the process should move through there, not hitting those red windows. Modern versions of that would be that you have an envelope curve. You collected from several hundred OK traces, and which you evaluated so far. So when the tightening is in process, the system is constantly checking on those on that envelope curve if the current trace is still in there, and can report immediately to the worker and can stop the tightening before the material or the product is damaged. And this is also very important, but you need, of course, data analytics for that. And if we really want to use that to find errors during assembly, then we need to, of course, have proof that that is really working. And this has to be done before you establish that tool in the assembly line. That means your IATF requires that you, for example, put in some products which are you tempered, and so you bring into the assembly system NOK products, and the assembly tool needs to detect them by itself and show a red light or an NOK. This is often not done or not in the consequence as needed. And the reason for that was that this is, of course, a lot of work, but still it's needed. Otherwise, you're flying blind. And the good thing about it is that VDI is also supporting that effort by requesting what is requested by product liability per se as well, that you prove that your tool is not just okay by means of, okay, the tool manufacturer did a good job and the specifications of the tool is okay. But no, you as a user of the tool have to prove that with your parameterization on your specific joint, you can get the quality you require. And therefore, you need to check the tool with the specific parameterization on the specific joint. And then you can see how much is the scatter and is the tool really capable not only to cover torque, but also angle. And nowadays, it's not an issue to really simulate any kind of trace on a joint simulator bench, or make a mechanical test joint if needed for the critical joints. Something similar you have with the process capability testing. This is also clearly a requirement from product liability point of view, from point of view of the VDI 2862, of course, and so on. Process capability testing in tightening tech is pretty special again, because as you might have figured already, in other joining technologies, it's always okay to just check on the final product if the quality is okay or not. But with bolted joints, there's almost no efficient way to do that in a big assembly plant. You need to come up with a decent way to perform that, and this is usually a static torque testing or residual torque testing. You might have heard of that, and this is described in the VDI 2645-3. But if you want to do that, and I will show you how it's done, you need to ensure that you have a capable parameterized tool before that. You have to have a stable assembly process, and you need to have a machine capability proof before you go to the PCT, because process capability testing is really the last line of defense. And I would like to show you why that is the case. So in order for anybody who is not acquainted with the process, I have a little video here. So basically what you do is you have a power tool, electric power tool, you tighten your bolt, and then after a while you go with a torque angle measurement equipment on that joint and tighten it a little bit further and take a torque angle trace. A torque angle trace could look like that one. Usually they are a little bit different, but I can show you later. And this is what you get. And the VDI in that specific standard covering the PCT said you can evaluate such a trace differently because every joint is different. So if you get into that standard, you might get confused because you can evaluate such a trace in very different ways. And it's always a static torque measurement, but the results are drastically different. And this is confusing people. And if you buy a testing wrench from us or any other supplier in that area, you usually have 5 different methods of evaluation. And depending on which method you use, you sometimes can have plus minus 20% different torque readings. And that's not easy. So most of the people are lost in space and don't know which point should be used. And that's also because many people did not really get the purpose of the PCT and tightening tech, because usually it's just to have a trend analysis. It's not so much what you would do with a joint analytics, where you really want to see what's the relaxation in the joint. It's about having stable torque readings over weeks, months, years of production, and see if something happens there with the torque readings, if they're going up or down. And the trend is relevant there, not so much the specific value. To ensure that this is easier for the quality assurance personnel, the companies in that area came up with some data analytics, of course. For example, what you can see here is somebody took in an early stage of assembly of a product 10, 20 traces of a stable assembled product. And the software is helping you decide which method gives the most stable result, and where the worker and the tester, the test personnel, has not so much influence on the scatter of the result. Because if you do PCT by hand, you have, of course, some influences by the worker. And that's also something where we see that we can also compare the tightening data with the PCT data, and then help the quality assurance personnel to decide if the data is valid and can be used, and with which method. Also, the VDI recognizes that in the past, many companies needed to use not just the torque angle measuring wrenches, but also fixed edge spindles, which sometimes even be used for production, and then they want to use it as a measurement equipment as well. This is, of course, a big hassle, and IATF per se is not happy if you mix that. Nevertheless, we see, for example, on a marriage station, there's almost no other chance to get the testing done, if not by a specific tool or measurement spindle. And what we did in the last 2 years, and I hope we finish our work on that in the next year, is we came up with a 2645-1, and there is all the requirements on measurement equipment for machine capability and process capability. And we also defined what somebody needs to do in order to use spindles and those tightening tools for PCT testing as well. So this is also really helping people which felt in the past really in a gray zone with their testing, but thought it was better than nothing. But this is really helping them to backing, that VDI is backing them up and supporting with real data and standards for that. If we talk about testing, and if we talk about IATF or ISO 9001, you always need to prove your processes with statistic methods. And usually all those international standards require that you make sure that your processes are correct on basis of ISO 22514. There are several parts of that, of course. And the problem for most of the people is that there's a big gap between your practical assembly work, your quality assurance with bolts and nuts, and the statistical demands. And this is a huge hassle. If you want to follow IATF on the 22514, which is one of the required standards in the back of the IATF, then this is quite a task, to be honest. So VDI was challenged for that as well. And that's the reason why, if you look at the 2645 series, the 1, 2, and 3 for machine capability, process capability, and measurement equipment capability, we were able to really take care of those requirements from the ISO and transform it into a practical approach for the tightening technology. And this is also important because if you want to fill up your data lakes and you not just want to swim in there, but use those data lakes in the future for Industry 4.0, you have to make sure that your calculations are right and the data you gathered is really meaningful and showing the way and leading the way. And VDI with those standards is supporting that and making sure that you're collecting only relevant data. So you see, we already almost at the top, and the top means for proof you need documentation, and there I think we have also in Germany, and which is available in English of course as well, two very helpful standards. It's the VDA 1 and the VDI 4500. VDA 1 is of course pointing toward the VDI 4500. If somebody has issues to sleep nowadays, then get at least the part 1 of the 4500 and read it, because there's a lot of good insights regarding what's the responsibility of any personnel in a company and what they need to ensure for documentation. And this is often not really precisely defined in a job description. Nevertheless, lawyers would point out that you should know that this is your responsibility as well. And so sometimes that's interesting to read and to help the company to get better. Nevertheless, I would like to just highlight the VDA 1 in one perspective, which is quite special. What you can see is on the left side, the 3rd edition, and on the right side, the 4th edition. And if you read the small printed stuff in the beginning of those standards, there's clearly highlighted that even so there is a 4th edition, it doesn't mean that the 3rd edition can be tossed away. The reason for that is that all those editions have a different focus area, and therefore it's important to not forget the old versions and make sure that you have covered those as well. For example, the 3rd edition is taking care of software and hardware requirements regarding archives, what is the needed IT infrastructure and something like that. But also the VDA is pointing towards the 2862 with respect on what needs to be checked, how it has to be documented, how people need to be qualified and such stuff. And what I found very important in the 4th edition was something like here, the documentation for machine capability testing, also for our fastening tools, and the process capability testing. The archivation time is 30 years. That was stated in the 3rd edition as well, but there was a lot of room for interpretation. And I struggled a lot and had a lot of discussions with people in that area regarding the timeline, because many thought it's just 15 years. And yeah, but nevertheless, they cleared it up, and it's 30 years, and that's important because that's how long it will follow you if you don't have made sure that your process FMEA was okay, the documentation was in place like the standards required to that time, and. But it's really helpful, and it's not too big to read. So yeah, that's our little pyramid. But we have one thing left to go, and that's competence. Because if you check on product liability, if you look at any of those standards we see here in the pyramid, there's always the requirement that only qualified personnel can be used for the specific tasks. And that's pretty ominous, or was at least in the past, because there was no standards really helping you on what does that mean. If you are a welder, then you know if you have a safety critical weld, then you need to pass practical and theoretical test every 6 months or something like that. Otherwise, you are not entitled to do that. The same for people who are calculating welds. And even for gluing, there is a European engineer title for that. And in the past, there was nothing like that in tightening tech. the German Fastener Association started with a fastener engineer, where I am now a tutor as well, a lecturer for machine capability and PCT. The possibility to study that is now there for 7 years, but of course the DSV is not big enough, and it was not structured well enough. So the DSV and the VDI joined forces, and we were able to bring up that standard, the 2637-1, within less than 2 years. And it's really helping everybody to understand what is their current job, what is their responsibility, and what do they need to know, and how they have to prove it in the end. And this is absolutely a must read for everybody in the tightening business. It's not just for people who parameterize tools, but also for people who buy bolts and nuts, people who buy software even are mentioned there, and also, of course, management and what they have to prove as competence in that field of expertise. And since this is such a huge pyramid, Industry 4.0 needs to bring that together. So the data is not lost in the beginning for the end, and the other way around, that we make sure that the competences are in place and the systems recognize a competent person or helps to train people as well. And there are good things which we can already see and which is already possible, and I would like to show you a little bit of that. For example, if you determine the assembly parameters in the beginning of a project, then you can already document that in a specific software. Those softwares can be also collect pictures, drawings, or whatever needed maybe later for the worker guidance. But also what we can do is use then, for example, hand-operated wrenches to check on prototypes if that's the calculated assembly values and target values are okay for that product. That's also if you go into joint analytics afterwards, if you really want to destroy parts, destroy the joint, if you want to find out what is the right PCT target value, this can be collected in such a software as well. And interestingly, and this is a huge step forward, if you then have the parameters for those wrenches for the assembly, it's possible nowadays to really give tools, power tools from a different company, those parameters by just a mouse click, and the tools have at least the basic parameterization already in place. And you can go then and do also the verification of the parameters with respect, is the error proofing okay? And you can do that by sending from the early analytics, where you collected torque angle traces. You can put those traces on those joint simulator benches by a mouse click. You send it to them wirelessly, and then they simulate the expected joint, and then you can check your power tool if it's capable for that. You get a CMK value, of course. And so you can also use the pictures and the data you collected in the early phase also to ramp up a fast worker guidance and other process quality assurance methods. And also if you later want to test your tool, it's nowadays no problem that such a testing device like a joint simulator bench recognizes immediately if somebody approaches the bench with a tool. The system then collects the needed parameters or selects the needed parameters, parameterizes also the bench and the simulation, and gives the okay for the user to use the tool later on, or it makes sure that the tool cannot be used until it's repaired. So I would say we have a lot of stuff already going on in that perspective in the tightening technology, but of course what's needed is a data exchange standard which has a global approach, make sure that the tool interchangeability is better. There are several approaches. MQTT, for example, is something I would like to mention here, but I would like to highlight here as an example the effort from the OPCOA together with the VDMA. So they came up to have the open platform communication, unified architecture for end-of-arm tooling in the industrial adjoining technologies. This is quite a topic for a work group, or a name for a work group, I have to admit. And their goal is really to make sure that through that standard, that you can just take a green tool and exchange it by a blue tool from a different manufacturer, and it's instantly working. And this is, of course, quite a challenge. And that's the reason why the work group set their targets a little bit lower. The first step targets are, for example, asset management, tooling, measurement equipment, and so on. Get basic results from the tools and the measurement equipment, also traces, of course, condition monitoring and events. So they have a tight schedule. They meet a lot, and they almost every important tool manufacturer is on board on that. But still, they have a lot of trouble to get that thing going. And one of the reasons is a pretty boring one, I have to admit. And this is that the terminology is not aligned. Means, I would like to give you an example. If you want to say that a specific point on the torque angle trace is the start where the angle gets measured, the torque value where the angle gets measured, then you have several terms for that. It might be angle threshold, angle triggered torque, angle starting point. So if you want to use IT infrastructure, and every tool manufacturer and every company and assembly company, OEM, uses different terms for that, then you might have the most sophisticated software in place, but of course the data will get mixed up and results will be messy. So VDI said, we take care of that big task as well. And so we spend more than 2 years now to build up a glossary on that. And we are hopeful to publish that on the VDI homepage in the next month, at least a first version, and we will build up on that. It will be in German and in English, of course. And we also want to give descriptions, what is meant by that. So every tool manufacturer, every company who wants to build up Industry 4.0 structure and want to gather data can use those descriptions and terminologies. And then, of course, for the user interface, they can do a different labeling. But at least the structure, the backbone behind is working well, and the data can be used. The VDI is paving also the way regarding qualified personnel. In Germany, at least, we have more and more academies helping the companies to get in a decent way the people qualified. We are not talking about hundreds of thousands of hours people need to spend to be trained, because we already have good people. But I'm pretty sure that we can streamline that effort, which is already done. And we also can ensure that we have a proper documentation later on. And then, of course, to make sure that we measure the right stuff and have the right data, because what's important is that we don't want to have bad data. Because if your server rooms are full and you're wasting money in your servers and you're just swimming in your data lakes and don't get anything out of it, then why do it in the first place? And then Industry 4.0 is lost. And that's my vision for also the expert systems of tomorrow. I really see that we still need humans for that, good qualified personnel here, and then bring it together with the hardware and software which is capable to really connect the dots together with the experts, and then we have a good future for that technology with the bolts and the screws. So I say thank you very much. I hope that was sort of interesting for you. And now I'm pretty happy to answer your questions.
Thank you very much, Markus. It was very enlightening and a very good overview. And in the end, I think we really could see the link to Industry 4.0 and to one basic element that we have been discussing in a lot of different sub areas in the industry, which is we still need human beings in the process that really know the cause-effect relations of what the electronic or digital systems have to deal with. So this is really a really important point also for us here in Brazil to follow up on. We have two questions so far via our Q&A tool here. The first one is from Emerson. Which VDA standard has a role for product safety that is common to be used in for R&D? That probably is quite a broad question in this context, but maybe you could refer to the most relevant VDA standards for the fastening technology in this context.
For product safety was the question, right?
Yes, exactly.
Yeah. The VDI is usually not in that area, but supporting then the European standards like EN 12100, for example. When you've done your risk assessment for the specific system, like pressure valves and so on, there is also a European law on how to safeguard such pressure valves and systems, systems, and the VDI is then consequently following up on what has to be done with respect to ensure the safety of what you have analyzed beforehand. So I hope this helps a little bit on that question. Otherwise, you just give me a call or write me an email if I did not get it right.
Perfect. Well, there were a lot of questions actually about sharing your presentation. I can answer on that we will send an email to everybody that was joining us today with the link to download your presentation. I think it's a lot of information to take in, and people are eager to take a closer look on that. I would like to take the opportunity just very quickly for us, especially to do further follow-up events and to really grasp the role of this new content for the Brazilian market. I would like everybody to take a very short poll with us that I'm launching right now, and just switching back to Portuguese just for a little bit to describe the question. Então, qual grupo de competência, né, dentro desses assuntos que nós escutamos aqui agora, desde a questão mais voltada ao cálculo, né, os diferentes níveis da pirâmide que foi descrito, vocês que estão nos assistindo consideram hoje como mais relevante no seu dia a dia? Essa seria a primeira pergunta. E a segunda pergunta como caracteriza sua demanda de conhecimento no contexto de aparafusamento. Aqui, mencionando mais uma vez, né, nós estamos estudando a fundo essa nova diretriz que o Markus mencionou sobre as competências, né, e os diferentes sistemas de quais competências, qual profissional precisa comprovar em que momento para garantir a transição ordenada para a indústria 4.0. Então, agradeço se vocês pudessem responder a essas perguntas aqui rapidamente. Vamos dar mais. We will give another 30 seconds for people to respond. In the meanwhile, if you have any further questions, please feel free to keep using the Q&A tool. Thank you.
If I might, of course, SCS is also located in Brazil. My colleague Frank Lobato is the team leader there. So if you want to connect with him and talk to him, just write me an email and I will pass through that. And he can answer you also in Portuguese, your questions, or we can work together on that.
Great. So almost everybody already responded. So close down the polling tool right now. So there were some other questions here, especially regarding traceability. I think you were talking about that a little bit already. The latest, if you have any news on that, or the latest developments on traceability in this context.
Traceability is a really huge issue. I have to admit, I was surprised when I got deeper into details with that, because I always thought in my tightening path that, hey, of course, calibration of torque or angle, this is a done thing. Nobody will bother on that. But as I found out over the years, this is really something in the making. There's a lot of research going on right now. We just changed or revised the standard of angle calibration, direct angle and indirect angle calibration. There is also, again, no standard available other than the VDI standards on that. And also what we see from the IATF respect is, of course, pretty hard to swallow for many. And this is also based on the ISO 9001, that the standards require metrological traceability. And that means it's not just good enough to calibrate at any calibration laboratory or internally. No, what the IATF pointed out pretty strictly, and on the national footnote in Germany, they also described it a bit in further detail for the ISO 9001, is that you need to have accredited laboratory for the calibration of torque and angle. And if you do a testing of your power tools, then that might be advisable as well. You can do it differently, but then you need to make sure that you also prove more or less the same level of qualification. And that's something you need to keep in mind. If we talk about accreditation of a laboratory, then this is not so much on that, of course, the measurement equipment needs to be calibrated. No, it's the accreditation is more or less also the proof that the people who are doing the calibration and testing are qualified for that, and the results are trustable. And what you also need to keep in mind, and that's also from the IATF requires an MSA, a measurement system analysis. And with respect to torque tools, there was almost nothing available to bridge the gap between calibration and MSA, because in the middle of that, there is also the CGK factor. So you need to have statistical proof that your measurement equipment is capable to be used for that specific measurement task. And more and more companies fall into that trap when IATF auditors put their finger in that wound and ask for relevant data and documentation. And this is really tough, and the 2645-1 will help on that. But there is a lot to be done by laboratories on one side and also on the users on the other side.
Great. One last question. I think that's also a future issue. Fabio is asking about the impact of electric cars in Europe, and how do you see the impacts on tightening technology, on the future of tightening technology in this context?
Yeah, that's very interesting. The German Fastening Association had a big research undertaking in the last 3 years, and they published the document, I guess, last year or something. And I used that for my keynote speak for the big workshop in Germany, because what they basically found out is that the big bolts getting less, of course, if you have electrification, and so also the weight of the bolts in the car and in total gets lower. But what they found out is that the total number of screws is even getting a little bit higher if you have electrified cars. And what you see there is even more challenging, because you have self-tapping screws more and more, not just in plastics, but also in metal and so on. So the challenges for the fastening people and the assembly people are getting higher and higher, because you not just have metric bolts there as much as you had in the past, which are pretty reliable and so on. So we will have a lot of things to think about and to change in the future. So we have a lot of research going on in Germany for different things, flow drill screws, for example. And also you can see that I'm working in the ISO, and for mechanical joining on sheet material, we are just about to have several standards, making sure that people who are riveting, who are self-tapping screws, flow drill screws, and so on, have a possibility to check on the joints, but also qualify the personnel. So you will see something coming up next year or the year after that.
Great, very interesting about this this report of the DSV. That would be very interesting. I think we can maybe send the link out to everybody who joined us today, who wants to.
Yeah.
Great. Well, I think we can conclude our webinar pretty much on time right now. Very German fashion, punctual end of this on this webinar. Once more, thank you very much, Markus, for joining us today, for sharing all your knowledge with us. We will, as I already said, we will send out the presentation in an email after the right in a few minutes. And please feel free to get in touch with us or with Markus if you have any further questions.
Looking forward.
Thank you very much.
Yeah, thank you for having me. Stay well and healthy.
Thank you. Goodbye, everybody. See you next time.